everybody. Today I'm going to be demoing something that we just got on testnet on Thursday. So it's a little bit rough, but we're pretty excited about it. This is going to be the foundation of Wormhole's what we call generic relaying, which is basically a very flexible way of doing arbitrary message passing, like remote contract invocations, multi-blockchain forwards, basically just like a very flexible system of exchanging data, tokens, whatever you want to do across many different blockchains. And so I guess before I get into it, just to gauge the room, who here is familiar with like interoperability protocols in general, Wormhole specifically? Just like raise your hand if you're like, good, man. Okay, so I'm seeing like a bunch of people that know roughly what the idea of moving one message from one blockchain to the other is, but maybe not so much the specifics of how that works. Cool. So actually, we don't really need this for now. I'll just nice freebie. Yeah. So basically, the idea of Wormhole is, look at this. Pretend there's nothing. So the basic idea of Wormhole is you can essentially think of it as emitting an event in the EVM ecosystem, but that event is observed and attested, or like essentially verified by the Wormhole Network as having happened. And so if you have one of these signed events, which we call a VAA, a verified action attestation, then you trust the Wormhole Network, then you know that actual event did in fact happen on some other blockchain. So this is a slightly like lower level primitive than a lot of the other interoperability protocols out there. So like the base level is just like, yes, this thing happened. But because we start at such a low level there, you get a lot of flexibility in what you can do with these things. So basically, if you know that something happened, you can deliver that as many times as you want to any ecosystem that can verify that message. So not just EVM. You can do that on Cosmwasm, on Aptos, Sui, Solana, Algorand. Really almost every major blockchain out there. And basically, any sort of network topology that you can come up with, or any sort of use case, you can build on top. So, for example, our token bridging layer is just basically a normal application on top of that core signed message idea. One of the problems with being so general, though, is that if your core primitive is just that a thing happened rather than that a message went from A to B, then you're basically leaving the integrator or the user to move that message from A to B and do what we call relay. Yeah. So basically, what I'm going to be demoing today is our solution or the sort of beginnings of our solution for solving that problem for you and being able to relay messages generically, and also in a very composable way. And yeah, so I guess before I get into it anymore, are there any questions? Did that roughly make sense? Okay, cool. So as I mentioned, this was hot off the presses as of Thursday. So I coded this up this morning. So it's a little bit raw. But I want to just first start off with taking a look at what you get. Is everybody here familiar with the toolchain Foundry or Forge? No? Okay. Okay, so basically, maybe if you've heard of Truffle or Hard Hat, or basically just a project scaffolding type thing like that. but so I just created a new project, just ran for Janit, and it gives you this like very simple, dumb little counter contract. And the basic idea is like you can increment it, and then you can observe that the thing happened, and it's even simpler than a hello world. So what I wanted to do is just show you like the hello world of wormhole message passing, which is we're just going to take literally this example and say, okay, what if you had now a distributed counter that's across n blockchains, and how would you do this? And so there's a couple of things. We're still going to have like the same increment endpoint. Now, because it's a distributed system, we're not going to have the ability to set it directly, and that's about it. So basically, in order to retrofit that counter example, to be able to receive a wormhole message and act on it, we just have to implement this interface, which you just have to have something that says receive wormhole messages. You're then passed some delivery data, and this has sort of useful information like what contract called initiated the message in the first place. Notice that this isn't an EVM address; it's just 32 bytes. The reason for this is this is not just an EVM API; it's an API that can support Solana or Algorand or any. All these different ecosystems have different public keys, and so we have a sort of a catch-all wormhole format, and also convenience helpers to go back and forth. The chain that it came from, and then also I'll get into this a little bit later, but if you don't use all of your budget, essentially we'll pay you back. So there's no penalty for overestimating how much something's going to cost you. But then what we're going to use for this really basic demo is this payload. The other part of this interface is over here, and these are basically other wormhole messages that you can tag that you want to be delivered along with your payload. I'm not going to go into that right now, but this is really where like the magic happens when it comes to composability and being able to do things that basically leveraging that like event-centric model as opposed to a message passing-centric model at the base level. So yeah, it's not really that much. We need to set up our constructor, depend on a couple of contracts that are going to be deployed on various chains. So the wormhole core layer, the wormhole relayer layer is what we call it, and then the wormhole chain ID that we're currently on. And then, the flow is pretty simple. So we still have the increment method. It looks exactly like the one before it. Actually, I'll go down a second. So after we run the constructor and set this thing up, we want to cross-register all of the different counters in our distributed counter network. Because that's an incredibly important use case that we're really proud of. We don't want just anybody to be able to sort of lie and say that they are a legitimate counter. So we cross-register all of these things, and then once that's done, if our counter is the one that gets incremented, we know to send a message to all of the other counters to tell them that we've been incremented. You should also increment yourselves. So we do that by just reading the other registered contracts in our network, and then that tells us the chain that we're going to and the contract on that given chain that we're going to, and then if we look at well, I'll just explain it here instead of looking at the interface, but on this iWormhole relayer interface, we're going to be using this send method, which takes in, where you're going essentially, where you want your refund to go, how much gas you want to buy essentially on the target chain, how much native currency you want to be handed on the, or how much money you want to spend buying native currency for the target chain, and then just an arbitrary bytes payload. This is a more limited overload that doesn't deal with like the additional messages. Yeah. So if we come over here, we just fill this out. We say that we want to buy 0.1 of the native currency, and we don't actually want any native currency on the other side. We just encode our counter. We actually don't really need this, but I wrote this example really fast. This is just an enum for whether we want to wait for finality versus just send a message immediately, and let the other, basically whether we want to take the risk of rollback or not. Yeah, so we do that. Then if we don't end up using all of the message.value that was passed in, we just refund it. Yeah, and then on the other side, we just check that the message came from one of our registered contracts, and then we increment the counter on the remote end. And that's pretty much all you need to get state transmission across any of the Wormhole connected networks. And I'll just show you how this works. So we'll deploy the contracts fresh. So chain 86 is AVAX, since we're on testnet in Fuji, and 14 is CLOB. Again, this is a little raw, just made it this morning. All done, so we deploy it and then we cross-register. And then let's say we want to increment on AVAX. See that the counter on both chains obviously starts at 0. And that was so fast that we didn't actually get to see the intermediate state there, but we do that again. Hopefully we'll get a little bit more lag this time. But yeah, basically, it propagates from one network to the other. We're only deploying on 2 chains right now, but can work up to n chains. All right, yeah. So there is that transmission delay. And so what's happening in the background is this message that we're emitting here. It's getting detected by a relayer that's monitoring the Wormhole network. This is an open and permissionless relayer. Anybody can do this relay. We have a default relay provider that does it if you don't care, but you can either run your own. We're also working to build a sort of decentralized proof of stake style relayer network that basically to determine who actually gets assigned to relay the message. But for now, we just have one. Yeah, so they see that message, they parse the information on what to do with it, and then they deliver that on the target chain. And that pretty much covers the like really simple use case. I'll pause for some questions here, and then I'll talk about some of the more powerful features that you can do with this, because this isn't like, this is cool, but it's not really scratching the surface of like all the cool things you can do with it. So, any questions here? Did that roughly make sense?
So is it required that we call the register back every time?
Sorry, say again?
Is it, I mean, is it prerequisite that register contact is to be called every contact?
I'm sorry, I just couldn't hear you.
I mean, you have this register contact. Is it required that we call it whenever like we get a
The register contact? So this has nothing to do with Wormhole. That's just like, so if I did this, it would work without registering them. Basically what this is doing is just, like, let's say we want to prevent somebody from like making a spoof counter that's like, let's say we have like a closed network of counters, and we don't want just anybody to like pretend to be one of our legit counters. That's what that's preventing. But if you want to be able to accept a message from anybody, anywhere, then you just don't have those lines, and you're good to go. Cool. So then, I guess I'll just describe a couple of the other more interesting things that you can do. So I think the big one is being able to basically specify other Wormhole messages that you want to be relayed like together with this message. So let's say there's like a third-party protocol that does something interesting, like let's say it's like a borrow lend or something like that, and they're going to emit a message saying something about like your collateral value on this chain or whatever, and that protocol knows nothing about your protocol. You can compose with it by calling whatever thing emits their Wormhole message, and then you just point to it using like their address and then the sequence number of their message for like nods. Not super important how that works exactly, but you can essentially build up a bundle of payloads that are sort of loosely coupled in the sense that they don't need to know about each other in order to like compose with each other. So maybe a more practical example of this is the token bridge, the Wormhole token bridge. So let's say you want to do, like you have an AMM on AVAX or something like that. And you want to be able to make it really simple for any user from any chain to be able to like provide liquidity on your AMM, on AVAX. But you want to make it feel as though that product is actually native on any of the Wormhole connected chains. So like basically every chain out there. You can actually achieve that without deploying any contracts besides just the contract on AVAX with this system. And the basics of how you do this is you would do a Wormhole token transfer on your source chain, let's say Polygon or whatever, and then describe, put in a data payload of saying like what you want to do with that. Maybe it's implicit in your application, but maybe it's not. And actually, you do two Wormhole transfers and then the data payload. And so if you don't have any contract on Polygon, what the user can just do is do one transaction for the Wormhole transfer, a second transaction for the other Wormhole transfer, and then a third transaction for sort of pulling the results of that together and sending it off to AVAX. What's really cool about that is that now you just need to, it's not a hub and spoke model. It's like purely a hub model where you don't actually need contracts on any of the spokes at all. And so just like in a little bit more detail how that would work. You would take these messages and redeem them in the token bridge. You get your tokens. You would then, call into the AMM to provide liquidity just like normal, and then you'd get, your LP token out. Maybe you do other things with it, but then using the same money that you spent in order to send the original message in the first place, you can have that refund credited towards essentially forwarding the message on to like either back to the source chain. That's what makes sense in this application. So person throws 2 random tokens in, they get the LP token out, and from the end user's perspective, it's as though everything happened on Polygon. Like, they don't need to be aware that the application is actually on AVAX. Like, obviously, they can be aware, not hiding it, but it's, yeah. And then, like, you can, well, I'll stop there. There's like a bunch of ways that you can like stitch these primitives together in kind of interesting ways, but did the idea of like pointing at another wormhole message, so like essentially like pointing at some event that happened either in your own transaction or in a different transaction, could actually be on a totally different blockchain. So you can actually go and say like, go grab this wormhole message that happened on Solana, and one that happened on AVAX and ETH, bring them all together and deliver them to Polygon, for example. Does that all make sense? Take that as sure. Let's see. Yeah, so there's a bunch more details about how like some of the cool things you can do with this, but the main point that I want to get across is it's now, like, you don't need to run any sort of specialized infrastructure yourself to do the relaying. It's now taken care of for you, either by just a default default relay provider if you don't care, or you can specify any number of relay providers if you do care. You can do one yourself, et cetera, et cetera. And yeah, it's basically this simple to go take any sort of normal application and make it a cross-chain application. And we should be on mainnet in like about a month, 2 months, something like that. And just sort of for fun, some of the next steps for us are allowing you to like batch all of those different transactions into one transaction on the source chain. So instead of these requiring like 3 clicks, it'd just be 1 click. But again, you don't need to deploy any smart contract of your own. This is just composing existing ones that are already there. And then the sort of third version of this will be a very simple instruction set to actually do that orchestration on the target chain, like the remote chain. So you can actually build, like stitch together a bunch of different dApps across arbitrary chains into one sort of cohesive application without actually deploying any smart contracts anywhere, which I'm very pumped about. So yeah, hopefully, we'll get some good docs up pretty soon, and excited for you guys to try it at some point.